Hello students, so continuing our lectures on spintronics, we'll first start with now a spin valve is formed when there are two ferromagnets and which are separated by a thin non-ferromagnet, and it's almost about 3 nanometers. So it's almost shaped like this. These are the ferromagnets. This will be the ferromagnets. And between them there will be non-ferromagnets. This is how the construction of a spin valve looks like. Now if the coercive field of the two ferromagnets are different, then it is possible to switch them independently. So it can act as a switch. Therefore, the parallel and anti-parallel alignment can be achieved. Normally, the resistance is again higher in anti-parallel case. It means if you have magnetization, this one in this case and this one anti-parallel case, then of course the resistance will be high. Whereas parallel magnetization gives a lower resistance. This device is actually called a spin valve. Now, looking to a different aspect, if drawing the spin valve once again, if the magnetizations are in opposite directions, in this case, say it is in this direction, and in this case in this direction, then the flow of electrons becomes difficult. Whereas if the magnetization occurs at a parallel magnetization, it means like this, then the electron flow will be, it suffers much less resistance, it can flow smoothly through the spin valve. Now, the key structure in these materials, these are also giant magnetic resistance material, GMR material, and the key structure is actually the spacing of the non-ferromagnetic material between them. Now, there is a tendency of the magnetic materials to align themselves in the same directions. So magnetic materials, they have a natural tendency to align in the same directions. By alignment, I mean alignmental magnetic moment. So the spacer is thin enough. So if this spacer, this one, if this is thin enough, then the influence of one on the other takes place, and the changing the orientation of one of the magnetic layers can cause the next to align itself in the same direction. So this can cause the other one, which may be in the opposite direction, to align itself in the same direction. So this is actually the coupling. This is also called coupling taking place. So the thickness of the antiferromagnetic layers influences the coupling of magnetic of the spin valve. Next material that we will discuss, or next phenomena that we will discuss, is called spin transfer torque or STT. Spin transfer torque is an effect in which the orientation of a magnetic layer in a terminal resistance or spin valve can be modified using spin polarized current. So using a spin polarized current, we can change the orientation of a magnetic layer. That means the direction of magnetization, whether it will be in this direction or in this direction, it can be affected by the spin polarized current. And now charge carriers, we know that current means, when we are talking about a current, we means electrons. So if the current flows in this direction, the flow of electrons is in the opposite directions. And these electrons have got a property which we all know is got a property of spin. They revolve around their own orbit. Spin, so parallel spin gives a magnetic moment in this direction, and the parallel spin will give magnetic moment in this direction. Now the electric current, when we talk about the current, this electric current is usually unpolarized. Unpolarized means that 50% of the electrons will have a spin in this direction, and the next 50% will have a spin in this direction. Now somehow it could change the ratio. So changing the ratio will cause the current to be polarized, spin polarized current. Now this spin polarized current is, if this spin polarized current, we call it as SPC, if this SPC is directed into a magnetic layer, the orientation of the magnetic moment, its orientation gets changed. And this can be used to treat oscillations or even a flip. It can lead to oscillations. The oscillations mean the magnetic, suppose magnetic moment can oscillate from here back to here. So it can consider an oscillation, but it can also flip. Flip means if it was in previous wave in this direction, suddenly after application of this SPC, it changes its direction. Now this is actually the torque. So this is the spin polarized current is causing a torque on the magnetic moment of the magnetic layer. That is, this is actually the spin transfer torque. The spin is being transferred into a torque, and this used as very much used in magnetic random access memory, and the phenomenon that is called STT RAM. And the advantages of this STT RAM is that it has a lower power consumption, and better scalability. or other conventional membrane devices.